All right, this is the practiced test for Chapter 3 in college algebra. We want to figure out what x values work to make this function okay. We are allowed to take the square root of 0, but we can't take the square root of negatives. So we need to think about what makes this 0. Well, of course, that'd be -4. So x equals -4 is okay. When I put in -4 there, -4 plus 4 makes 0. I can take the square root of 0. But then, can I have larger negative numbers? Can I put -5 or -6 in there? Well, if I put like -6 in there, -6 plus 4 would be -2. It can't take the square root of -2 because it creates imaginary numbers, right? So I need to have things that are bigger than -4 or equal to -4. So if you think of the number line, you got -4 here. It could be -4, but it needs to be numbers that are bigger than -4. So in interval notation, you'd use a bracket, -4, comma, infinity. Boom. Here, I can't divide by 0. So what makes this 0? So we need to move the 25 over. So I get x squared is equal to 25. And then we take the square root of each side, which of course gives me plus or minus 5. So x cannot be plus or minus 5. So if you have 5 or -5 there, it'd be 25 minus 25 is 0. And you can't divide by 0. So those numbers are excluded from the domain. Now in interval notation, this would look kind of crazy. You do like negative infinity, and you do all the way up to -5, and then union, and then between -5 and 5 would be okay, and then union, and then after 5 to infinity would be okay. So I'm excluding -5 and +5. I think writing it that way is probably better than all that mess. The range of the function be the highest and the lowest. So we got the highest value in the y is 5, and the lowest value in the y is -3. So the range is the y values, so it's -3 to 5. Local maximum. When you're doing these, it's really the output of the function. So the highest local max is right there. So it's going to be 5. So it's 5 when x is equal to 2. The x-intercepts are where it crosses the x-axis. Those are easy. -3, -1, and 4. And then when is the function -3? No, -3. Oh, there's a discrepancy here. So it's -3 when it's 5. So I have a little difference between the answer key and that because I changed it. And then intervals of decrease. This is when it's going down. So I get out the yellow highlighter. It's going down here, and it's going down there. So it's those two intervals is where it's going down. So the first interval is from -4 to -2 in the x. So we state the x's. So between -4 and 2, it's going down, and between 2 and 5, it's going down. So that's interval notation. We don't talk about it decreasing at a point. We talk about it decreasing on an interval, so we don't use the brackets. We use the parentheses. Okay, next page. Odd or even. So what we do is if you take out -x, or take out x and replace it with -x, so that's how we tell. And we can do that here, right? So if I take out x and put in -x, then you raise negative to the 4th power, and it's just this -5, and then back to x squared plus 6. So when you take out x and you put in -x, and the formula goes back to the original, that means it's an even function. If you take out -x or take out x and y and replace them with -x, right, and it goes back to the original function, then it has origin symmetry, then it would be odd. So that's the review for that. So if you take out x and replace it with -x and y and replace it with -y, and it goes back to the original, then that's an odd function. That wouldn't happen here because you'd have a negative over there. But definitely when I take out x and replace it with -x here and here, and then you square it and raise it to the fourth power, it just goes back to the original function, and that means that it's an even function. And then you're just basically testing whether it's odd or even, whether it has y-axis symmetry or origin symmetry. Okay, describe the transformation. 3 spaces to the which. That's right 3. And then up 2. So you're just writing that out. Tangent, or the secant line from 2 to 5. So here's the graph of the parabola, and 2 is right here, and 5 is right there. So we just want to know the slope of that, and we want to write the equation of the secant line. So by drawing this in there, I can tell the slope is up 1 over 1, up 1 over 1, up 1 over 1. So the m secant is equal to 1. Now, if you need points, right, this would be 5, 1, 2, 3. And this point right here would be 2, 3. So if you 2, 0, my bad, 2, 0. So if you subtract these, it'd be 3 minus 0, and then 5 minus 2. That's how you find slope, is you subtract the y's, you subtract the x's, and you get 3 over 3, which is equal to 1, right? Or I just counted the boxes. You can tell that it goes up 1 over 1, up 1 over 1. So we want to write the equation of the secant line. You can actually see that it continues down there. The y-intercept is -2. So if you just continue this slope of 1 down there, it crosses at -2. So the equation is y is equal to slope of 1x minus 2. But let's say it hit at a different point, right? Well, you do y equals mx plus b. And you're like, do I know a y value? Yeah, y is 0. You can use either point. I'm using this one. Do I know an m? Yes, the slope is that, right? And then do I know an x value? 2. So I put in 0 and 2 and for my x and y, and then plus b. So 0 is equal to 2 plus b. Subtract the 2 over, and -2 is b. So then your y-intercept's -2. Your slope is 1. There's your equation of your line. But you're just figuring out the average change. So if you're on a curvy road, you got to go around the curve. But if you had a helicopter, you could go in a straight line. That would be the average change, the slope of the secant. All right, now we have to draw these out. So I gave you an original picture here. So it's kind of it's like a V, but it's got the little nose cut off of it. And we're going to do the following things with it. So we interpret this function plus 3. That means we're going to make the whole function go up 3. So it's right here. So now it's going to go to 6. 1, 2, 3. So that should be 6. 1, 2, 3, 4, 5, 6. So there's 1, 2, 3. Yep. And then it has the slope of -1, -1, -1. So that means this point right here went up 3. So it'd be 1, 2, 3. So it should be like that, right? Yeah, there's 2 dots in there. So that moved up. Then it goes over 1 like this. And then it goes up 1, 2, 3 spots this way diagonally. 1, 2, 3. And boom. So there it went up 3. All right. The next one is down here, left 2. So it's going left 2, which means everything gets left 2. Notice I'm chickening out on doing this one because that has all the stuff to it. So left 2, originally it's right there at 3. So left 2, it's going to put it over here. So left 2, so it's 3, left 2 would be right there. Okay, and then it's got this little thing like this, and then it goes up like 3 boxes like so. And it goes 3 boxes diagonally this way. And I think that does it, right? Uh-oh. 1, 2, 3. 1. Yeah, that's right. That looks dandy. That looks dandy. All right, now. Whoop, whoop. This one has 3 things going on. It's flipped over the x-axis. Well, that flips over the x-axis. That flips it over the y-axis, and it's 2 times as tall. No. All right, so how do we do that? Do this. So I'm going to take this point right here. I'm going to flip it over the x-axis and the y-axis. So we're going to flip it down 1, 2, 3. And then you're going to flip it over here 1, 2, 3. So it'd be like 6 spaces over this way. 2, 3, 4, 5, 6. Okay. So if you flip this down here like this, that flips it over the x-axis. Then you flip it clear over here, it flips it over the y-axis. Draw it in. Okay, so that takes care of the two negatives. The negative inside flips it over the y-axis. The negative in front flips it over the x-axis. The 2 makes it twice as tall. So now I have to incorporate that, twice as tall. So I have a general idea what it is here in my little cheat mark here. So 1, 2, 3. Now twice as tall, if it's at 0, it's not going to be twice as tall. It's going to stay at 0. So I just go over 1, 2, 3, and I go over 3, right? So these two dots are not going to move. And then twice as tall means it's at, or twice as short, or whichever. Twice as down as far. 1, 2, 3. So now it's going to be down at 6. So we go 1, 2, 3, 4, 5, 6. And then the same thing over here. 4, 5, 6. So it's going to be down like so. That's 7. That's 6 right there. So we got to go for 1, 2, 3. Oh, it is at 7. Oh, you're right. It is at 7. It's at this one. So let me fix that. Let me get rid of this dot. I got to put the line back in. Fix it here. Fix it there. Yep. It is over at 7. So it's 3 this way, 6 down this way, 3 this way, and 6 down that way. So this makes it go down twice as far. There we go. There's the answer, the correct one. Okay, question number 8 is where we find the maximum or the minimum of something. We got to make a function, and then we got to graph it. All right, so here we go. The volume of this box is volume is equal to x times y times volume is equal to x times y. Then I gave you this equation because it says that the perimeter can be no more than 108. So we need to solve for y and put it in here. So we have one equation in terms of x. So the volume is x by y. And then, so I got to solve this. So I got 108. I got to subtract the x over. I got to subtract the 2x over. And I got to subtract, or get equals 2y. So it's 108 minus 3x is equal to 2y. Then we have to divide by 2. So to get it by itself, so we get 54 minus 3, 4 equals y. So that's what y equals, because this is the helper equation, because it says the perimeter of it can't be any more than, perimeter of one side of the box can't be any more than 108 inches. So I kind of gave that to you. That's the volume equation. Put this inside of here. So v is equal to x squared times y. Y is now 54 minus 3 halves x. And this is a function, so you could write it v of x. You type this into the graphing calculator, and you're looking for the maximum volume. And after you graph it, it turns out that x is equal to 24, and the volume is 10,368. When you graph this function, that's where the relative maximum is. Mr. Jackie only has 15 minutes to make a video, and I'm right at 14 because of the way that the program works. So I didn't have time to graph it on the calculator, but you can graph that, and that's where you'll find left, right, guess, and you'll find the maximum volume. And that's it.